Good morning, Amherst. Monday, April 27th, 2020. Welcome to the next unit, acids, bases, and salts. All right, so we're going to start out with some nomenclature review. I don't want you to get too hung up on it. We've done all this before. If you don't remember it, that's fine, because the nomenclature is not a big part of it. You've got tables K and L to help you out with a lot of it. This unit will have tables K, L, and M we'll come back to. So here's the review for today's lesson. Acids, bases, and salts. Acids, for the first part of our unit, are something that starts with or contains hydrogen, and the hydrogen ions are what makes an acid an acid. So it's hydrogen with a nonmetal or hydrogen with a polyatomic ion. This is a binary acid. This is a ternary acid. Binary acids got the prefix hydro and the suffix ic, and ternary acids were never hydro. So HCl, that's hydrogen, nonmetal, so it's going to be hydrochloric acid. In ternary acids, we said the polyatomic ion, if it had the suffix ate, becomes ic, ite becomes us, got a bad case of aticitis. So something like HNO2, NO2 is nitrite, table E would tell you that. Ite becomes us, so NO2 is nitrous acid. And NO3, nitrate, would be nitric acid. Second example of binary here, H2S, it's hydrogen with sulfur. Hydro, you might think sulfic acid, it's not bad, but for sulfur and phosphorus, they throw in the extra syllable. Hydrosulfuric acid. We did this earlier in the year. A new wrinkle, we've talked about it a little bit, are organic acids, carbon-based acids that end in the group COOH, carboxylic group there. So you've got R is the rest of the carbon-based molecule. You've got a carbon with a double bond to an oxygen, a single bond to an oxygen, and a hydrogen. And this is the hydrogen that has a tendency to detach, become a hydrogen ion in solution, and that's why these things act like acids. We'll talk about this in much greater depth in a little bit. But something like CH3COOH, it's the same thing. Sometimes I take this H and I write it out in front. So it's H, CH3COO, which is the same thing as H, C2H3O2. Well, if you base it on the number of carbons, there are 2 carbons here. They call that F. We'll get that in organic. But if you take this C2H3O2 or the CH3COO as a -1 ion, that's acetate. So acetate becomes acetic acid. You know this as the acid of vinegar. Organic acids are acids. So if they end in "ku", that's an acid. Bases, something that is ending in the polyatomic ion hydroxide. So it's either a metal or a polyatomic ion that precedes it. So something like NaOH, sodium, that's group 1 plus 1, OH is -1, that's sodium hydroxide. You've got a polyatomic ion like NH4 positive, that's ammonium hydroxide. If you had another kind of base that had a metal with choices for oxidation state, for example, if we had CuOH taken twice, hydroxide is -1, total of -2. Copper plus 2 would balance that, so it's copper Roman numeral 2 hydroxide, which you might recall as cupric hydroxide. The lower form, OUS, is less. So copper plus 1 would be cuprous, copper plus 2 is cupric. And once again, do not get bogged down too much in the nomenclature. That goes back to earlier in the year. It's not that big a part of our unit. Of interesting note, alcohols are not bases. Alcohols end in OH, but that OH is not ionic. So if it's carbon-based, carbon, 3 hydrogens, and OH, that's methanol. It's an alcohol. It's not a base. It doesn't conduct electricity. It doesn't have any of the other characteristics. So here would be like a simple alcohol, the simplest one, methanol, 1 carbon, meth. We'll get to there in organic. This H does not detach. This OH does not detach. These are all covalent bonds. It's a non-electrolyte. It's a non-conductor of electricity. So they don't call this hydroxide. They call it a hydroxyl group, a functional group. Whereas in something like NaOH, this OH minus is an entire entity in and of itself. It's a mobile polyatomic ion in solution that would conduct electricity. So acids ionize in water. They start out as covalent, and then they act like they're ionic. So something like HCl, that's a covalent bond here between hydrogen and chlorine. But if I put it into water, the hydrogen separates. You have H positive ion aqueous and Cl minus ion aqueous. Those are mobile ions it's going to conduct. It's appropriate to call this hydrogen chloride when it's pure. But if it's in water, they call it hydrochloric acid. I don't know why I pluralized that, but we'll get rid of that. So if it's an organic acid, here's CH3COOH, that's ethanoic acid again. I'll move it over here, you can see this. This is going to be an actual equilibrium that sets up much further to the left. We'll get there. But this hydrogen is going to detach, not all the time, less than 1%, but some of the time. So you have a hydrogen ion, and then what's left over is the acetate ion. So these are mobile ions in solution, so acids are indeed electrolytes. Acids conduct electricity. Bases, they're already ionic, so we don't say they ionize in water, they dissociate in water. The ions separate from each other. Sodium hydroxide, you put it in the water, the sodium goes one way, the hydroxide goes another. They're mobile ions, they conduct electricity. Bases are electrolytes. Alcohols are molecules, they are entirely covalent, they do not ionize in water. So if I take something like methanol, liquid, put it into water, I get methanol aqueous. It stays intact, none of the bonds are broken. There are no mobile ions, there are no mobile electrons, they are non-electrolytes, they are non-conductors. No mobile ions or electrons. They do not conduct electricity, non-electrolytes. Something else we've done, neutralization reactions. So you take acid plus base, it gives you salt plus water. So you take the hydrogen from the acid, the hydroxide from the base, that's going to make water. Take the positive part of the base with the negative part of the acid, that's going to make a salt. So you get the moles of hydrogen equal to the moles of hydroxide, which will equal the moles of water. So for example, if I had lithium hydroxide and sulfurous acid, I've got 2 hydrogens here, I've got 1 hydroxide there, I need 2 of them, put a 2 here. That's going to give me 2 waters. Then I need to put my salt together. Say, oh, lithium, that was in group 1, it's +1. SO3, that's -2, do the crisscross thing, Li2SO3. So 2 lithium hydroxides and 1 sulfurous acid give you 2 waters and lithium sulfite at LiSO3. Similar, as hard as it would get, this is harder than your homework. What if I gave it to you in words? Phosphoric acid with barium hydroxide, what are you going to get? I don't see hydro here, so this must be a ternary acid. Ic goes with 8. Alright, so no hydro. It's a ternary acid, it goes with 8. Phosphate, table E tells me it's PO4 -3. It's an acid, acids start with hydrogen, it's H plus 1, do the crisscross thing. Phosphoric acid is H3PO4. If that was troublesome, phosphoric acid is on table K. Barium hydroxide. Barium's in group 2, it's a +2 ion, hydroxide is -1. Do the crisscross, so that's barium and 2 hydroxides. So I have H3PO4 plus BaOH taken twice. Lowest common denominator, lowest common factor between 2 and 3 is 6. So to have 6 hydrogens, put a 2 here. To have 6 hydroxides, put a 3 here. That'll give you 6 waters. Put your salt together. Barium's +2, PO4 is -3. Crisscross them, there you go. Which leads us to tonight's homework. I think I emailed out an electronic copy, but we've got copies out, and this one looks like number 10 got crossed out. I think that says hydrosulfuric acid, but I can't say for sure. So I don't really care if you do that one. But basically, you're going to do worksheet 2, acids and bases. You're going to tell me, is it a binary acid, ternary acid, or a base? And then come up with the name. So this is a nomenclature review. Here it is, nomenclature at the bottom. I give you the name. You're going to classify it and come up with the formula. And then on the back, here are some neutralization reactions where they've filled out the reactants and products for you. It's just get the hydrogens equal to the hydroxides equal to the waters, and the salt is already put together for you. Here you have to do the double replacement yourself. And then numbers 11, 12, and 13, which one's not a base, which one is not a base, and which one is a base. Look at table L. All right, we'll pick it up from here tomorrow. Talk to you soon.